solve 4 problems. The first ones I'll go through pretty quickly because you've seen them before. You've kind of done something like this before, but I just want to jog your memory and get you used to this. Okay, so notice how this first problem, you can't solve with same bases. I cannot write 16 as like 3 to a power, right? It's not going to be 3 squared, 3 cubed. It's not going to happen. So in this kind of a situation where same base is not going to work for you, that's where you just take the log of both sides. So that's a technique just called taking the log of both sides, where now I'm essentially using a base of 10 in order to solve this problem, rather than attempting to use a base of 3. Exponent comes down in front. And then I hope you guys are comfortable and happy with this idea that log of 3 is literally just a number. You plug it into your calculator, it behaves like a number, it is a number. So I can divide by it and get x by itself just dividing both sides by log of 3. By the way, this is an exact answer. So if you're told to give exact answers, that'd be it. If you want to find your decimal approximation, you just plug in log of 16, divide by log of 3, and you got 2.52. Of course, that's an approximation, so just be mindful if you're being asked for exact or approximates. Next one essentially looks the same, but what kind of log base do you think would be really nice to use here? Base E, maybe. Yeah, because if I just take natural logs of both sides, well, we already know that natural log is the inverse of e to the x. So this side just drops and becomes x. This side is natural log of 10. Again, exact answer. If you want to approximate that, you just drop it into your calculator. Natural log of 10 would be 2.303. This next one, I can't just drop it, like I can't just take a log of both sides yet, because I need to isolate the exponential portion of this problem and then go. So I'm going to start by adding 12 to the other side. What, 156? Okay, and then take the log of both sides. Guys, do you mind if I do this a little quickly and just drop the exponent down in front already? Okay, because I know that my 3x plus 11 is going to go there, with log of 17 here, log of 156. And then I can divide both sides by log 17 and ultimately take more steps to get x by itself. I'm kind of starting to feel like you could finish this problem on your own. So big takeaway here is just please isolate the exponential before taking the log of both sides. That's the whole point of this. So isolate your exponential and then take the log of both sides. Just getting a little bored of that problem already. Last one. Cool. Just smidgens enough time. This is actually a super cool problem. If you're solving something that looks like this, what you're actually solving, you might not even see it yet, is something similar to a quadratic equation. Oh, nice. Just need a couple of head nods. This is just e to the x squared. So if I do some kind of u substitution and just let u equal e to the x and keep solving this problem, it's just 2u squared minus 5u minus 3. Factor it. You've got 2u minus 3 plus 1. So I've got u is equal to negative 1/2. Eric, would you close that? Thank you. And don't forget to back substitute at the end. So I found my solutions that u are equal to this in here. But now I need to back substitute because u is actually e to the x, something like that. And then e to the x is equal to 3. And using natural logs, I can finish solving this, taking the natural log of both sides. But I want to pause and ask you a question first. Can I take the number e, which is about 2.7, raise it to a power and get something negative back? Think about the number 2. 2 squared. 2 to the 1/2 power. 2 to the negative 1 power. None of those actually make the result negative. There's actually no solution here. You can't take a positive number, raise it to an exponent, and get something negative back. It's not going to happen. I don't care what that exponent is. By the way, if you try and take natural log of negative 1/2, it comes up with an error anyway. So if you didn't notice this right away, then you can just check with a calculator. Here I might take natural log of both sides. I know that ln and e cancel, so I've got e equals ln of 3, which is about 1.0986. I think this is by far the hardest one in the homework set that has you doing a U sub in order to solve something like this. So just keep your eye out for when that problem does come up, because it's in there. But otherwise, you guys should be pretty much set to crank out a lot of the homework.